Hello. So good morning everyone. So today we are here to discuss some medium level problem on dynamic programming. So let's see if all of the question is not completed. So we move for the next session. So till now starting. So we are covering the medium level question of DP. Okay. So it's randomly selected question. So in next session we try to solve in pattern wise problem of the DP. So let's see the problems. So first problem is a program to find a amount of water in a given glass. Okay, so let's see the problem station. There is stack of water glass in the form of Pascal triangle, and a person wants to pour a water at the topmost glass, but the capacity of each glass is 1 unit. The overflow occur in such a way that the 1 unit divided 1 unit 1 by half of remaining unit get into the bottom glass on the both bottom right side. So we pour k unit of water into the topmost glasses. So task is to find how much water is given to the cth glass or the rth row. Assume that the enough glasses in the triangle till no glass overflow. So we are given with an example. So question number one. So let's see question number one. Explain that. Question number one. Question name is find the amount of water in a find a water in a given glass. Okay, glass. Okay, so this is the question and we have to answer this one. So a stack of the water glass in the form of Pascal's triangle, and a person wants to pour a water in the topmost glass, but the capacity of this glass is 1 unit. So flow occur in such a way that 1 unit, after that 1 unit, half of its unit get into the bottom left and the other half will be bottom right. So we pour k unit of the water, topmost of the water. So task is to find how much water is that in the cth glass and the rth row, cth glass of the ith row. So k unit of water is poured. Okay, so we have to find the uh, we have to find the how much water is there in the cth glass of one cth glass. So cth find the amount of water in cth 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 glass in r row. Okay, so let's see. So in a Pascal triangle format, all the glasses are given. So k is equal to 3. After the first glass is filled, so half of this inside this. So after the first glass, two unit of the water is remaining, and they will spread equally into the glasses of the second. Therefore the glass of the second row and the first column will be the 1 unit. So answer will be second row and first. cth glass. Second row, cth glass. This is like an example. Okay. and when k is equal to 2, but 2 unit of glass. So one example is that we have k is equal to 2, and we have to find second row, second glass water unit. So after the first glass, 1 unit of water is remaining, 1 of unit and half of. So equal distribution. So how we think for this question, medium level okay unit. So answer is output will be output. So out is equal to 0.5. Okay. So after the first glass, so 1 unit of water will remain and they will spread equally on the two glasses of second row. Therefore, the glass. mm, So according to me, this question will be solved by using dynamic programming. So this question solved using dynamic programming. So how? So dynamic programming. Let's see how we solve this question. How we solve using this. So approach is to solve the water overflow in involve a simulation of water distribution. So actually the question of dynamic programming, because the water overflow, mm, mm, water overflow. Okay, water overflow. So water involve the simulation of water distribution. Simulation of water distribution. So simulation of water distribution. Okay, through the grid representing the Pascals. So grid, it is a grid. So using the Pascal triangle. Okay, Pascal triangle, a simulation of the water distribution of the grid in Pascal's triangle. Pouring the water, and then each glass algorithm check the water exceeded the capacity of 120. If the overflow occur, excess water evenly distributed to the left side or right side directly. So each cap is maximum of 1 unit. This process repeated iteratively until the target is reached or not. Finally, the amount of water in the specific thus ensuring no glass exceeded the maximum capacity. So how we solve this problem? So let's see how we solve using dynamic programming. Uh, Dynamic programming, water overflow. Okay, what is the idea of the code? So we have to return in double format overflow water. So in which we have given integer k unit int r, row and the column. Okay. Okay. So we create a matrix to simulate. We create a 2D matrix. So vector of what? Double. Its name is memo of row and the vector of double one. So consisting of co- uh, consisting of rows and all value is the 0.0. Okay. Let's see. Starting 0 row 0 column, 0 row 0 column. This means that initial top of water is k unit. So initial water is filled with the k unit. Okay. Simulate the water flow through the triangle. So simulating the water flow through the triangle. So what we do, we run the loop in the rows. So row is equal to starting with a 0 and is row is less than is equal to r and row r minus 1 or row plus plus. Okay, then column is equal to 4 and column starting with the 0 and column end with is equal to rows till rows. Okay, and column plus plus. So how you calculate how much water overflow? So how we check? Double excess. How we check? Excess is equal to maximum of 0.0 into the memo of rows and column minus 1. One unit is filled earlier. Excess water denoted by the excess water is a maximum of 0,00 or the memo of previous answer minus 1. Okay, if excess is greater than is equal to 0, so what we have to do? Distribute equally. So greater than 0, so we have to first fill value 1, fill the value of rows and column with one value. Okay, and flow to the bottom rows. So flow to the bottom rows. So memo of and if is equal to and flow to the bottom row. So row plus 1, column remains same, plus is equal to excess divided by 2. Okay, and row and divided to in next column B, row plus 1 plus column plus 1 plus is equal to excess divided 2.0. So to which we see the answer. So return what is the return the water in the target glasses. So we have to return the water in the target value and target glasses. So we have to return minimum of what 1.0 or memo when have to specific row. So r minus 1 or column minus 1. Okay, so which we have to return the for the specific row and column. So simple question, simply mm, simply we are given the k unit of the water, so poured into the glasses, and if a water overflow, the overflowed water distributed equally in the both side of the glasses. So the glass format is given in the Pascal's triangle format. So we have to find the maximum amount of the water represented in the specific row and specific column. So let's see the algorithm steps. So algorithm steps are as follow. First of all, first of all, we created in the main function. We have to write main function. We have to write create a 2D 2D vector which store the value 2D vector to store the value of water at specific row and column. Okay, after that we move forward for initializing the water at the topmost. So simply initialize, like we have created a memo. So initialize the water with the maximum amount we have right now, and then simulation start of for loop. Okay, the for loop, so in which the row move from 0 to 0 to r, the given r value, and the column moves to 0 to the specific rows. Okay, till specific rows. Okay, column plus plus, and then after we have to check the excess amount of water. How we check? So for the excess amount of water, so we check through excess is equal to maximum of 0 comma and the present in the previous column, excess water present in the previous column minus 1. So this is the excess amount of the water we have. So what we have to do, if the excess amount of water present, if the excess amount of water is greater than 0, so in that case we have to equally distribute. So let's distribute in the rows and then after the column. So simply we have to assign memo of row plus 1 and column remains same. In this case only, plus is equal to excess water divided by 2. And for the column section, for the next column section, so is equal to row plus 1 and column plus 1. In this case, plus is equal to excess of water divided by 2. And in final we have to return the answer in a specific rows and column. So specific rows and column. So in this case, minimum number of water present in that specific row and column. So I will check through this minus 1 comma c minus 1. So this is whole procedure for solving this question. Mm, So okay, take a break for 2 minutes. So we move forward after this break. So let's move forward for the next question. Is my live is coming? Mm. So next medium level problem is longest common subsequences. So we don't discuss the whole question because we have previously discussed many times. So we only explain the algorithm pseudocode. So let's see. The question is question number two, LCS. Okay, LCS. So LCS. So just see the algorithm. What so you are given with the strings s1 and s2. Your task is to find the length of the longest common subsequence. If there is no common match in subsequence, a subsequence is a string that generate through the all of these things. So you know everything. We just simply write the approach and pseudocodes. So what are the? We don't write the recursive code. We just memorize everything. So in this case, in the function inside function, what we have to write, simply check the base case. Base case. So base case suggests that if m is equal to 0, and invalid case if m is equal to 0 and n is equal to 0, this means that we have to return 0. Okay. So if the string matching from the previous from the backside, so if any of the string from s1 matches with the string 2, in this case we have to return the answer. We have to move forward. So in this case 1 plus and the function in s1 s2 and minus 1 or n minus 1. Okay, we have to move in this direction, and then the memo code will be there. If I use memset, so don't write this one. In else case, what we have to do? In else case, what we have to return? In else case, we have to return the minimum of what? The function having m or n minus 1, comma, the function in which m minus 1 or n. Okay. This will be the answer. So store and return. So this is a pretty straightforward question. So let's move for the next question. Yes, and let's move forward to the next question. Let's see what are the next question. LCS. After that, LIS, longest increasing subsequence. In last lecture, we already discussed one. So let's see. Question number three. Question number three. LIS. LIS, longest increasing subsequences. So how we will solve this question? Simply see the pseudocode. The function inside the function, what we have to given an array of size of n, the task is to find the length of the longest increasing subsequence, the longest possible subsequence in which the element of the subsequence is sorted order in descending order. So how we have to write? So there's like 3, 3, 10, 20. So we simply move for the memoized code. So inside function, let's write the base case if index is equal to 0, if index is equal to 0, in this case only one answer will be there. So return 1. Okay. If already exists, if the code, if idx, it's only one thing is changing. If idx is already exists, so return this memo of idx. Okay. So after that we check when we have to find the maximum one. So consider all element of the left is equal to and recursively compute the LIS ending from this. So we have to check. Okay. So for loop, run a for loop in, in previous starting with the 0 value to uh, less than idx. So less than idx, and check if all the elements are greater than or less than. If array of array of array of previous is less than the current value, array of idx. In this case the increasing subsequence maintaining, so we have to find the maximum value. So max is equal to maximum of mx or comma lis. Okay, array is passed. Now and now current become mm, previous and the memorization, and plus one through this, so we can find or store the value and return, and store the value in memorize function and return. Okay, we have covered lis. Where after that we move forward for the next question is irid distance. So it is a pretty straightforward question. So question number four is irid distance. Okay, so in irid distance we are given data, you given two string s1 and s2. So we have to perform the following operation so that s1 become s2. The task is to find the minimum number of edit to convert s1 into the s1 is to s2. So what are the steps through which we can achieve? So inserting, removing, replacing. Okay, replacing. So through these three steps we achieve the following answer. So inserting mean adding one character before or after any index. Removing a character from the s1. Replacing mean replacing a character at any index s1 with some of the other character. Okay, so example for we have to make geek s1 gs. Okay. So what we have to do? We simply convert S1 into S2 by inserting S between two consecutive V, or either to remove S from the S2. No, to make S1 to S2. So we have to make from S1 to S2. So S1 to S2 banana. So in this case we simply add S. So it become equal. So how we perform this illustration? The in every index we have to think either we insert, remove or replace. So every index we have three options. This means if we think recursively, we will reach to the 3 to the power m plus 1 m plus n time complexity. So we don't try to solve using this one. So what we have to do? Mm, we solve using memoization technique. So let's solve using memoization technique. In memoization technique, we simply got the time complexity into the order of m into n. So let's see. Here's a code. Here's a function through which you have to write the code. So if okay, if m is equal to thing in function we have given this one. In function we have given s1, s2, s1, s2, n, m. Okay, all these things are given, and so firstly we have to write base case. What is the base case? So base case will be mm, base case. What if our s1 is equal to 0? S1 equal to 0. How much element have to add, remove or replace to become s1 s2? So we simply insert that much of element to become s2. So we have to return n. Okay, after that what if for s2 become 0? This become 0. In this case, we have to remove S1 all character. So return M. Base case completed. After that, if the element already existed, because we are inserting removing from the both side. So if the value is already present, if already exists, if memo of M or N is not is equal to -1, so this means that it already exists, so return this one. Okay, return this one. So we have to check if our S1 is equal to S2. S1 is equal to S2 of that element. In this case, we simply move forward. In this case we have simply move forward, um, and simply to return what, the function edit distance function s1 s1 s2, and simply move in both both the strings. Okay, what if this condition is not true? If What if condition, and what is the else condition? So else condition, we have to perform any of this operation. So in this case, what we have to return, memorize function of what. So we have to find minimum of what, minimum of all three function. So what if we insert? So inserting mean incrementing the value of inserting, deleting, and replacing. So edit distance become edit distance. What if insert s1, s2, and the m or n minus 1. So when we have inserting, deleting, same, s1, s2, m minus 1 or n. Okay, replacing ed s1, s2, m minus 1, and n minus 1. So with these three steps, we reach the following answer. So this one is a simple question of edit distance question. So let's move forward for the next question. The time complexity is order of m into n, space complexity is order of m into n. So let's see next question. So the next question will be largest divisible subset. Largest divisible subset. How we achieve to this question? So let's see. So question number what? Question number 5. Question number 5. So find the largest divisible subset in an array. So largest divisible subset in array. Okay. So how we perform? How we think. So given an array, find the largest divisible subset in a given array. If there is a multiple subset of the largest size, return the lexicographically greatest one after sorting in ascending order. So subset is called divisible if the every pair x comma y in a subset either x is divisible by y, yeah, y is divisible by x. Have to check. So largest possible subset we are given with the just we given so given a array, given simply array in which 1, 16, 7, 8, 4. So we have to find the largest subarray in which every element are divisible. So one, see in the output subset, for every each of the pair in the first element divide the second and second divide first, like this. So every element divide each other. So in this, the answer will be 1 comma 4 comma 16. So in which every first pair divide the second pair and second pair divide third pair and third pair divide so large. So this one is a largest divisible subset in array. So we have to choose at every index option either we choose or not. So every index we have choice and we have to select from starting to end. So the time complexity, if we think of generating all the sub array and checking all the things to in we reach to the n square for the every sub array, and at every sub array we have to check whether to add or not. So the power, so time complexity becomes subset, simple solution generate all the subset for each of the pair and we have to check all the pair it is divisible and satisfy the condition not a modulo b is equal to 0 or b modulo a is equal to 0. So so let's see how we write for the brute force approach. Size starting from this j is equal to I plus 1 if subset of I divisible by the subset of j and the subset of j divisible not to return false, if condition true is return true, so valid. So int lexicographically compare. So there is a very large approach and this one is a very large approach. So we solve using recursion. So in recursion we reach to the power n into n, so time complexity. So what we have to do, if we have to check if I is greater than this, if current element is greater than rest of side, so rest is equal to current, if current of side is equal to rest is equal to side. So let's trick recursively. So okay, next approach will be solve solve recursion. Okay, solve using recursion. So what is the time complexity? Time complexity will be n squared for the selecting every value n into n for each of the iteration. So let's see the code. Let's see the code. Inside the function, what are the things are given? So in function there is a result things and the current portion is given. Okay, so if I is greater than is equal to array dot size, if I is exceeded the array size and and also check if current dot size is update as if the current subset is larger and lexicographically greater. If current size is greater than result dot size, in this case we have to update. In this case we have to update the value. So rest is equal to current. Okay, now rest become current. Okay, if okay, and another one, if current size is greater than is equal to rest dot size, rest dot size, and also have to think for end case, and cur is given then rest. So in this case we also, if current size given and current is greater than rest, so in this case also we have to assign the result as a current value and then we have to return then we have to return either case we have to return. So check for the include the current element if divisible by previous element or not. Current dot empty if previous element of I is a previous element, so we have to push the value into side the current and recursively move for the next one and pop back. So try every possible value and finally exclude the current value and then this one. little bit trick one. So little bit trickier one. So we have to solve. We managed to solve. Okay. In memoization approach. In memoization approach. So we have to largest firstly simply sort the value, create a parent, and like this. So this one trickiest question. So let's finish this session. We solve the five question on dynamic programming, and this one is pretty good questions. So let's see how many questions left there. Okay. Until largest subset value we have reached. So knapsack problem, simply see also see the knapsack problem in 01 knapsack. Question number 6, 01 knapsack. Okay. So you are given with an item where each item has some weight and profit associated with that, and also a bag with the capacity. This the task is to put the item into bag such that the sum of the profit associated with them is maximum as possible. So constraint is here that either you put the item completely into bag or cannot put at all. So weight capacity is given as 4, profit will be 1 2 3, and weight will be 5 4 3. So how we put, there are two items which have weight less than or is equal to 4. So if we select the item with the weight 4, the possible profit will be 1, and if we select the item with the weight 1, and possible result profit will be 3. So we try to maximize the profit. So note that we cannot put the both the item with the weight 4 together. So let's see the recursive solution. Pick the item. Item is included. Optimal of subset. Item is not included if not in optimal subset. What you have to do? So let's see the recursive code. Recursive approach one. Recursive approach one. Simply inside the function, what we have given inside the function, only things are given as value array, value vector, and the weight array, and the n size. Okay. So the base case is that base case will be weight and n. Base case will look like that if n is equal to 0, this means that there is no value of n, and also if weight is equal to 0, in this case we have to return 0, no profit. um, so when we have to initialize the pick value, so if the weight of n minus 1 is less than is equal to weight, we have to check if we selecting the weight is less than that weight. So in this case we have to pick is equal to value of n minus 1 plus move for the next value. So in this case reduce the weight size, so weight will become weight of n minus 1, and rest of the thing will be the same. Rest of the thing, so weight will be reduced, value will remain same, and the weight and the n minus 1. So we move forward. Say in the case when we don't pick, not pick condition, so not pick condition will be look like simply not picking. So in this case function will be same as function will be weight, value, value array, weight remains same, but we simply move forward. Okay. So from picking and not picking we have to return the answer, so we have to return max of pick or not pick. Okay. This one is a recursive approach, so we have to find return main function, we return w n or n. Okay. So recursive will be it times complexity will be but every index we have to think of picking or not picking, so that's why become so our time complexity become m complexity term to the power n. Okay, so we have to memorize this one. So let's memorize this code. Let's memorize our code. So how we memorize? Let's see. All the things are similar, but simply we have to add a 2D vector, because two things are changing, our index and the weight value. So n plus 1 row plus column. So n plus 1 for the rows and weight for the weight value. Okay, so in this case, how we write? Vector of vector of integer of what? dp of size n plus 1 comma vector int equal to weight plus 1 minus 1. Initialize all the things with the minus 1. Then simply pass inside the main function. Check if we have previously calculated the same subproblem, return the same one, and stored all the values inside the memo function, return it. Okay, this one was simpler one. So we also finished the 01 knapsack problem, unbounded knapsack. Unbounded knapsack. So unbounded knapsack. How we see? How we solve from the unbounded knapsack? Given a knapsack wave has capacity set of an item, certain value of this. The task is to fill the knapsack in such a way that we can get the maximum profit. The different from the classical knapsack problem, here it allowed the unlimited number of instances. So if we are provided with the unlimited number of instances, so all the codes remain same. If I reach to the end of this value, so we return 0. Consider the current item only if its weight is less than is equal to, and then we have to find the maximum weight. So take condition will be placed only, but one thing is change. If weight of I value is less than capacity, we take the value, but we don't move forward. Okay, I remain same. If we don't take that value, we have to skip that one and move forward. So I plus 1, rest of thing will be similar one. So in memorization portion, we also have to return a 2D vector. Okay, capacity plus 1. If we don't take I plus 1, if we don't take until the weight value is less than the capacity value. Okay, till now longest common king. So till now we cover 6 to 7 question on the medium level of the dynamic programming. So in next session we cover some medium and 1 2 hard question. So let's end the meeting.